Previous video, we talked about infinite series. So infinite series is adding up infinitely many numbers, and finite series is adding up n numbers. Now, one question that we have to think about is when you sum up infinitely many numbers, right? Think about, picture this in your mind. You have infinitely many numbers right in front of you. You want to add them up. Do you think the sum is equals to infinity, extremely large, or the sum is just equals to a real number? So that is what we have to find out. So in this example, do you see that I have two infinite series? Why? Look at the top of the sigma. They terminate at infinity, right? So that means we are adding up infinitely many numbers. Now, you might be thinking, all right, so since you are adding up infinitely many numbers, the sum must be huge. So they must be both divergence. Is that really true? That is what we have to find out. So before we start, here is the result. So the first one, I already know the result. The first one is converge, and the second one is diverge. So even though you are adding up infinitely many numbers, the sum is not always infinity, which is diverge. So let's do the math. So number one, we have the sum. N goes from 1 to infinity. 1 divided by n to the fourth plus n squared. You might need to use your calculator because we are going to do some approximation. So they are asking me to calculate the first 8 terms of the sequence of partial sums correct to 4 decimal places. So the first one is I want to find S1. What is S1? S1 means the sum of the first term. So when n is equals to 1, I have 1 to the 4 plus 1 squared. That is equals to 0.5. And then what about S2? S2 means the sum of the first two terms. So you are adding up A1 plus A2. So A1 we already know that is equals to 0.5. What about A2? A2 means when n is equals to 2, so we have 2 to the 4 plus 2 square. So that is equals to 0.5 plus 1 divided by 1 over 20, that equals to 0.55. Oh, one thing, if you are doing this on your paper as well, I want you to, write this number out because we want to make an observation, this fraction. So you do have to work the exponent out. I need to compare the fractions. All right. So S3. So S3 is A1 plus A2 plus A3. So A1 plus A2 is already equals to S2, right? So that means we are taking the 0.55 and then we continue at that point. So if you don't want to jump that fast, it's okay. We can go a little bit slower. So A1 we got it. A1 is equals to 0.5, and then A2 is equals to 0.55, and then A3, you plug in 3 to the n, so that is 1 divided by 3 to the fourth plus 3 square. So overall you have 0.5 plus 0.55. Oh, this one actually you don't have to work all the way through. As long as you keep this will be fine. So this is a 3 to the 4 plus 3 square. So that is approximately equal to, this one you do have to approximate, 0.5611. And then S4, that is equals to the sum of the first 4 terms, A1, A2, A3, A4. All right, so A1, A2, A3, we got them from the previous 3 lines, 0.5 plus 0.55 plus the A3 0.5, and then A2 is 0. Actually, you know what? Here is what I am thinking. This, as we move on, this will take forever to write. So here is what I am trying to do. I will just take the S3, which is 0.561111, and then add A4. So this one is just plus 1 divided by, when the n is equals to 4, we have 4 to the 4 plus 4 square. That's just approximate. So that is equals to 0.5648. And then S5. So S5, that means we take the S4, right? So we take the S4, which is 0.5648. And then we plus A5. So that is 0.5648. And then plus 1 divided by 5 to the 4 plus 5 square. That is approximately equals to 0.5663. All right, so at this point, do you see that as n goes up, look at this, denominator, and this denominator. Now, one thing that I want you to see is as n goes up, do you agree that the denominator is getting so big? So 1 divided by such a big denominator is equals to a very tiny quotient, right? So a very tiny quotient added to the 0.5648, that is not going to change too much, right? So that means as we keep moving, I expect to see the sum stay around 0.56. Do you see that after S2, we always start with 0.56, only the last two numbers are adding up, right? Do you see that? The reason is the denominators are getting so big, 1 divided by a huge denominator is equals to a very tiny quotient. So that means as you move up to the next partial sum, you will just add a tiny little bit of quotient to the previous sum. So that means the sum is not going to change much. So let's keep moving because they are asking for 8 terms. So we have S6, so that is the previous sum, which is a 0.5663, and then plus A6. So we are taking 0.5663 and then plus 1 divided by log 6 to the 4 plus 6 squared. Look how tiny the quotient is, right? So when you add it to the 6, you only have 0.5671. See? 56, 56, 56, right? Only the last two numbers are adding up. And then S7, you are taking the 0.5671 and then you add 1 A7 to it. That is not going to change much. So 0.5671 and then plus 1 divided by 7 to the 4 plus 7 squared. Look how tiny that is. So that is approximately equals to 0.5675. So you only add 4 to it. See, the sum is small. So S8. So that is equals to the previous sum. And then add one more term to it. So that is the previous sum plus 8 to the 4 plus 8 squared, very tiny quotient. So the sum is equals to 0.5677. So one observation we see right here is as the sum becomes really big, not sum becomes really big, as n goes big, the denominator is big. 1 divided by a big denominator, you get a small quotient. So that means as you accumulate the partial sum, you are only adding a tiny little value to the previous sums. As a result, the sum of the sequence is not going to change much. So now we go back to the problem. So do you see that that goes from n equals to 1 all the way to n equals to infinity? So you are adding up infinitely many times. So the idea is this: as n approaches to infinity, so as n approaches to infinity, you are adding a very small, or let's use the word small, very tiny value to the partial sum. As a result, that is not going to change the sum too much. So that means here is my conclusion. As n goes to infinity, so do you see that they are all start with 56, so only the last two digits are changing, right? So here is my conclusion. As n approaches to infinity, the sum approaches to 0.56. So even though you are adding up infinitely many numbers, so what? The sum is very close to 0.56. So that is a real number, so the series is convergence. That's how you solve this problem. So we have one more. We have a sign. Is the sign going to be convergence or divergence? So if you take a look at the screenshot, I already wrote a divergence. Let's find out. Okay, in the meantime, I would like to switch to another color. So the sum, this is an infinite sum. So n goes from 1 to infinity. We have sine of n. So if you think about the graph of sine, as n goes to infinity, sine of x goes to infinity, what's the graph look like? First term, we have a1, so which is sine of 1, right? Or what mode do you use? When you evaluate this on your calculator, use radian mode. How do you set the calculator in radian mode? On your graphing calculator, there is a mode key right next to the second. You click that mode key, make sure your calculator is in radian. So that is approximately 0.8415. and then S2, you take the previous sum, 0.8415, and then plus A2, right? So that is 0.8415 plus A2, that is a sine of 2. So that is up around 1.7508. And then S3, you take the previous sum, and then you add the next term to it. So you have 1.7583 plus sine of 3. So that is approximately equal to 1.8919. And then S4, take the previous sum. It looks like we are doing accumulation, right? We are adding up one values to the top of another value. So we add A4 to it. So we have 1.8919 plus sine of 4. So that is approximately equals to 1.1351. And then S5, we have 1.1351, and then we add the next value to it. So that is 1.1351 plus sine of 5, again, radian mode. So that is around 0.1762. Looks like we are decreasing. So S6, we take 0.1762 and then plus sine of 6, right? You add the next term to it. So that one you have negative 0.1033. We are still decreasing. How about S7? You take the 1033, negative 0.1033, and then you plus A7 to it. So that is negative 0.1033, and then plus sine of 7. This one is approximately equal to, you want to take a look at this, 0.5537. So that works like the graph of sine, right? So starting at 0, and then you go up, and then you go down, and then you go up. So going up and down, up and down, up and down. So the range is oscillating between y equals to 1 and y equals to negative 1. And then S of 8, that is equals to S7, so which is the previous sum, 0.5537, and then plus A8, so that is a 0.5537 plus sine of 8, that is approximately equals to 1.5431. What does that mean? That means as we move on, so the pattern looks like this, right? As we move on, we are unable to determine the sum. So as n approaches to infinity, we are unable to determine the sum. So that means the series is divergent. Other than infinity, we have one more possible conclusion. So for B, for number 2, as n approaches to infinity, unable to determine the sum, so that means the series is divergent. So other than getting an infinity, we can also say getting an undefined, DNE, right? Something like that, DNE. When the sum cannot be determined. All right, so that will be the end of this video. If you think my instruction is helpful, let me know in the comment section below. Please like, subscribe, and share. Appreciate your help a lot. In the next video, I have more to say about a geometric series. It's a very popular series. So I will see you in there. Signing off for now.